So we are now officially starting our meeting, our webinar. It's 12 noon Eastern Standard Time. My name is Andrea from Trax, and I wanted to welcome you here today. While we give some more attendees a moment to join in, I wanted to tell you a little bit of what's happening at Trax and just some upcoming events that we have. So today we're meeting for our August webinar from our Trax webinar series, exploring solutions towards green infrastructure in railway applications with Geogrids. Isabel Perez from Terrafix Geosynthetics is here with us to host this meeting with us. And Andrew Koyman, our Trax board secretary. So welcome. Coming up, we have our annual charitable golf tournament, September 29, early in the morning. We meet at 7:30 for a breakfast and then some golfing. We are still taking some suggestions and voting for the charity that will benefit from this year's tournament. You can register at trax.ca/golf22. Also in September, we have another webinar called Improving Track Availability. This will be hosted by Rashid Dord, Senior Track Engineer from the City of Ottawa. And he was also eager to present this to you at Trax Rail Day, and we got caught up in that storm. So he's eager to present this to you. This will be September 14 at noon as today, noon EST. And big news, we have some news that are going to be rolled out in a few days. At the end of the month, we will let you know more, but in the next few months, we will be hosting the Rail Awards. Trax Rail Awards are coming. We are very excited to be able to do this for our industry, and, you know, stay tuned. So without further ado, Andrew, thank you for being here and representing the board. I'll leave you to it.
Sure. Thanks, Andrea. So again, Isabel has joined us here to make up for a presentation that we missed earlier. We're pretty excited. She's with Terrafix Geosynthetics. They're a member of Trax. She's going to show us how geogrids and reinforcing systems can reduce cost and materials in transportation infrastructure and solve specific civil and geotechnical problems. It's an approach that meets provincial standards, environmental assessments, maintenance standards. They fit in asset management systems and as much some other, whatever constraints are in your project. Isabel has 15 years of national and international experience delivering solutions for infrastructure projects. She's offers a unique and balanced blend of technical knowledge and business-to-business acumen. And with that, go ahead, Isabel. Welcome.
Well, thank you again for this opportunity and for allowing me to present something that I believe has a lot to do within our industry and a lot of benefits that end users and so many stakeholders can take into consideration. And thank you, Andrew. Thank you, Andrea, for being with me in this webinar. And to all of our audience, thank you for your time. Andrea and also Andrew will be monitoring the chat. So we drop off any inquiry or any comments as we go, and hopefully by the end of this webinar, I also be able to deploy a small demo where you can see the real action from design perspective, how we can contribute to your projects. So just for kind of the start of the meeting and why it's important, this topic is rail is actually the principal way to trade goods, at least overall. So has been a huge component how we can move large and also heavy loads of or volume of goods distance to rail. So also rail sector has been taking a lot of attention in North America, and not just for the current, let's say, rail corridors that we have in place, is for rail expansion. We've seen that the demand of rails and freight is increasingly going up over the years, and not just that, even sometimes as designers or as consultants, we've seen the volumes and also the weight of those trucks has been increasing over the years. So the importance is that combines speed and energy efficient about moving goods, as I mentioned, and recently Transportation Canada released a measure that says that Transportation Canada approve and encourage change in rail safety. And rail safety is not just about the rail itself, but it's also about how we design tracks and how we can enhance or incorporate certain measurements to ensure that the tracks are in a safety standards, and how we can also be able to be more sustainable with those. So the purpose of this presentation is to combine both statements, be sustainable, but also how we can kind of think out of the box and we can meet the demand or the increasing demand that we are having. And the next slide, we will be talking about that. So just, I want to also give the credits. We had a webinar hosted by Professor Errol Tutumer, and he is principal for the lab test of University of Illinois. University of Illinois has, which is located around Chicago, has a huge, let's say, importance or influence into the all in situ lab test and research with CN and CP. Actually, during the presentation, I'm going to talk about some facts, functions, and historical information, but also I'm going to be referring to a third-party validation and also University of Illinois in situ test and research. So something that can validate all the stakeholders and can put you in perspective what is going on in North America, talking about rail industry. So in this presentation, which will be accessible of any of you guys, if you are interested, Professor Errol provide me the permission to mention most of the materials that we talk on January. But what he said is North America, well, just be focused in the US, has more than 140,000 miles of track network, where Canada has almost 50,000 kilometers. And again, those tracks are already built, and the idea here is not just to maintain and preserve that network, is also to expand that network. So it's not a surprise that here in GTA we see a lot of rail expansion, not just in light transit rail, but also heavy duty, and as well as infrastructure that support our ports and major connections with ocean freight as well, and other type of metals. So having said that, our goal here is not just to support you with the current infrastructure, but also to help you from design stage into the upcoming projects and design build projects that are happening right now. So in the next slide, I will be talking further about what we mean or what we stand for when we talk about the freights or the weight of those kind of cars has been increasingly happening during those years. You see here when we see, when we talk about rails in most of that network, that at least the Northeast Corridor network, and most of the network, we combine light transit with heavy duty traffic. And in the heavy duty by itself trains, we see the axle loads that goes anywhere from 36 tons or almost 40 tons, and as well as some other that actually use or is part of the use of those infrastructure. Having said that, from design perspective, we also can assure that you meet or have enough safety factor to be able to cover increasing weight tracks over the years. So in this presentation, we'll talk briefly about everything and how we can be covered or how we can enhance safety factor on those. So the next slide will be. So again, as I mentioned before, we combine on the existing infrastructure light and heavy duty shipments, and due to increasing demands, also trying to maintain, because it's really hard to say, but it's not hard to say, but it's really hard to do it. Try to maintain some sort of safety measurements as well as efficient and reliable operations. We received inquiries so on and so often saying how we can build this properly and avoid certain maintenance and rehabilitations, and which will lead in a line interruption, how we can do it better. So this presentation will try to, or will include part of what we can consider as an action plan. So again, as I mentioned, the demand is really high on top nowadays, and how we can be sustainable, and as well as kind of look or think out of the box on how we can come up with a measurement or an action plan that is able to meet the demand without compromising the performance or the requirements, the design requirements that we have to meet, talking about rail tracks design. So again, freight volumes have been going up, as I mentioned before, as well as material costs, labors, and environmental restrictions. And something that must be going down or has to be addressed is how we can lower the maintenance and how we can incorporate part of the existing materials, because ultimately resources are limited. So we have, generally speaking, in Ontario, 25 million of cubic meters are disposed every single year. That also includes rails, but also include roads and so many other projects. So at the end of the day, how we can be sustainable and how we can maximize the existing resources that we have. And ultimately, we will say that improving track performance can deal with those as a challenge. So how we can kind of maximize the use of the elements that we have, which again, it will lead to a less soil disposals, but also will lead to a more sustainability, because we're able to maximize what we have without compromising the performance. So that's something to think about during this presentation. I will give you a lot of insights how we can address those. So again, as this presentation, we start with some statistics and some facts about our industry. And based on that, I will say that the track substructure, so we're mostly looking about the subballast and subframe when we talk about substructure. Annual cost is $2.4 billion. The maintenance that takes to maintain those existing infrastructures will take $2.4 billion in substructures. Having said that, after analyzing kind of how much money we have to spend to maintain those, what will be the main problems? So you see here some red signs when we talk about subgrade shear failure, when we talk about extensive settlement, ballast problems due to poor drainage, pumping and water. So then we'll see like water is an issue here, as well as drainage problems when we talk about the subgrade. So we talk water within the subgrade and water within the substructure. So you will see here there is a pattern, and water in this case represent #1 category for substructure failure. And when we say failure, failure that leads into maintenance and rehabilitation. And the second issue that we understand on this slide is subgrade shear failure. Means subresidence, like when the subgrade is not capable or at some point cannot address the current load that the track bed is putting into a pressure. So then we will see the subgrade shear failure as a #2 issue. So let's go into the next slide and we'll expand that further. And again, part of those numbers that you will receive at some point and actually be recording to this webinar has been released for the transportation infrastructure, okay? And based on that, we will also be developed some sort of parameters or inputs where we say where ended up, like what type of challenge we need to address in order to avoid those issues. So in the case of how to avoid or how to elongate certain structures with less maintenance and less rehabilitations, we have to do some action plans. And in the case of these action plans is how we can enhance drainage. So if not, water is #1 issue, how we can enhance the water flow and how we can, let's say, allow a certain water flow that keeps our track into shape. When we talk about gradation as well, when we talk about drainage, is how, like for moisture retention, how we can, again, enhance the water flow and keep the aggregate clean and be able to, let's say, build or design with confidence. And when we talk about inspection, what type of materials are we going to use and how we can also enhance, even at some point, the strength of those materials or the performance of those materials, or how we can restrict, in the case of track stabilization, how we can decrease or restrict aggregate movement. So again, when we talk about and starting, let's say, from bottom to top, in this case, so people often believe that when you have any subgrade issue, in this case of foundation, in geosynthetics or geogrids will be suitable for this application because you can enhance the performance of that structure. In this case, will be having a reinforcement system. It will be able to dissipate the load in a wider section, so therefore it's less stresses under the surface, in this case on the subgrade. But we also have some findings that it also can be, when you have a firm subgrade, it can enhance the performance of that structure, but maintenance reduction. Next slide, I will show you the two different scenarios. So again, when we talk about, and we mentioned that before, innovation, what we can do differently to meet the demand, and not just sometimes meet, but also exceed, that will be able to save a lot of the money that is invested right now in maintenance and rehabilitation, in creating new lines or enhancing or kind of investing in new sections or building new tracks. So in this case, design approaches, materials, as I mentioned to you, the type of materials that we're going to use, and construction techniques can certainly improve rail infrastructure. So in this case, whether it's soft or firm subgrade, and we talk about subgrade as part of the foundation. So we can certainly say that we will be able to reduce the aggregate thickness or the aggregate that it needs to have, or from design perspective needs to have on top of that, even at some point, subballast and ballast, and even the bedding. But with a firm subgrade, so okay foundations, we also can say that we can maintenance reduction solutions. So by restricting aggregate movement, by enhancing water flow due to the confinement, we can certainly say that we will be able to elongate or have a higher design life with a reinforcement system rather than not having any reinforcement system in place. And just to have a quick sample of what I'm saying, so then it will be visual for you guys. So let's say we have a certain subgrade, so in this case 42 kPAs, and we need to build let's say 400 mils or above a foot of subballast and ballast. So with Geogrid, and this is a demo that maybe later on in this presentation I will be able to deploy, but just for the sake of this example, we can say that not just we can reduce carbon emissions, but we can have a more efficient, and efficient, when I said efficient, is less thickness, but without compromising the performance, and even with less money. So sustainability doesn't mean that it will cost you more. Is how to build in a more smarter way. So we have also, and we will be able to provide some environmental costs, as well as some other costs that are associated with building a thicker section that not just will cost you more in terms of money, and it will cost you extra time to build or to construct, but other type of inputs that can help you to build with more sustainability, like water, like fuel that will be need, less amount of trucks, so means less also damage around the surrounding areas. Most of the time when we talk about ballast construction equipment damaged a lot subgrade conditions, because most of the time the subgrade will be exposed. So there are some things that we can go in that way. So if you, Andre, if you want to go next. So yeah, when we talk about subballast and ballast function, we say that both of them are aimed to prevent and enhance that track stability. So when we talk about ballast, it's mostly to provide that stiffness on the structure, and due to that, for sure, well, let's say provide drainage. In some cases, this is kind of, or is in between a question mark, or how we can enhance that. But also the function of the subballast is provide that frost protection, and as well as for sure create that separation within the ballast and the subgrade. So at some point there are other question marks. So if those two elements or two cross section are built with that function, why they are failing? Like if the subballast, one of the main function is frost protection and act as a separation between the ballast and the subgrade, why we still have some subgrade pump ends on the surface of the tracks? So again, it's not just build it properly, but how we can enhance, or how we can enhance the safety factor that those sections are all built properly. So on the next slide, I will show you how Geogrids in this case can certainly enhance that confinement and that interlocking effect that we need to keep the aggregate at place. And by doing that, we will enhance the water flow. We will also kind of add as an, or include as another a material or component, and enhance that separation that needs to occur between the subgrade and the ballast to keep the material clean, to enhance the water flow, and certainly to enhance that stiffness of the material. So taking into consideration as a system, so the geogrid and the aggregate will work together, as you see here on the top side of the pictures, is how we can influence that confinement and that interlocking effect through the section, where we can restrict or minimize at some point. Let's say avoid can be an aggressive term, but we can certainly say that we are able to restrict and minimize aggregate movement. And that makes a lot of sense when we talk about rails, due to the vibration and the conditions that is exposed or naturally exposed. So having said that, and just giving you a small background of what geosynthetics, in this specific case, Geogrid, can do into your structure. When we talk about subgrade stabilization, and let's say it's in a roads where you have dynamic loads on the surface, and again, that cross-section is aimed to address most of the load. When you have a geogrid that plays in this in the upper section, when you see all the stresses due to the traffic or the upcoming traffic on top, and you will also see kind of the green line as the influence or load distribution within your cross section. When you don't have any enhance of a separation layer or any reinforcement at place, you will see how the load is exactly distributed in an area. What's happening now is when the subgrade is not competent to address that loads, at some point the subgrade will rot and the material will find, or the aggregate will find a way kind of to accommodate, and at some point you will have rottings, and that type of failures, it will be visible on the surface. So the main goal of the geosynthetics is not just to add that tension membrane where it can kind of hold the weight of the material, but it's mostly to create a system, a flexible system when the load can accommodate, and actually a flexible system will the load will have a better load distribution, and the system itself will be connected. When I'm saying that on my hands is the system will be connected in a way that it will be able to address the load and working together with bed soils or less compromised area with more compromised area. It will kind of build a uniform section. Well, we will try, or at some point, this is what the system aims to do, is try to avoid any possible failure. And when I'm saying that is at some point, we as a consultants, designers, or part of the industry, there are some things that we can control and there are things that we are able to control. So the things that we can control is what is the current foundations that will counter into a site. So when the project is given and you have the borehole information or the geotechnical report, you have to start with a foundation number. Something that you cannot control because it's given, is the current conditions. And sometimes we have to deal with very problematic, and when we talk about problematic, it means like a lot of drainage and filtration issues, different type of materials, contaminated soils, some environmental restrictions that limit the consultant or designer to remove and replace, or on any other type of, or maybe utilities that you cannot go under and proper build a desired cross section. So in this specific case, the geosynthetics can help a lot on avoiding or addressing those issues and build with confidence. So when we talk about, for rails, when we talk about the layer or the section of the influence, if you have any projects, feel free to reach out. And again, is valid because it's a second opinion that you can get. We are also able to back up your design with a preliminary design and get along with you with site assessments from design all the way to construction, site assessment, site meetings, and report or design. So, but when we understand kind of the behavior or the performance of the subgrade, we will say, even from design perspective, the critical application will warn you that if you are in a fully confined zone or transition zone, our goal is to take advantage or maximize the use of the geogrid. So therefore, the further you go from the geogrid to the aggregate, you will allow the aggregate to move. So kind of the interaction or the confinement zone will dissipate as you go further. So at some point, we will inform you how you can maximize the use of this system at place, and where is the time of the decision that you will have to say, okay, after 450 mil, if you click next, it will be the fully confined zone, something that we use as a design guideline for crane path or working platforms, and even sometimes track design. So we'll say fully confined zone will be 6 inches or 150 mil, and fully and transition zone will be 450 mil or slightly less than 1.5 foot. So we'll say that as a general guideline recommendation. If you want to go next, and I will expand that further. So when we talk about the importance of track substructure, something that we already discussed about the failures is how we can make it better. So In this case, the ballast will address most of the load, but how the subballast can also enhance the performance of the ballast, and how we can separate and avoid stresses within the subgrade and avoid that failure. So in this specific case, building a better subballast, bridging and building the subgrade, or allowing less stresses within the subgrade can make a lot of sense when we talk about dissipating or reducing that failure portion that we may have when we have truck designs. So again, when we say build a better substructure, can also make a lot of sense with the terminology that is called geotechnical asset management, how you can do smart investments on that specific sense, and how you can be more sustainable. And when you think about it, it makes a lot of sense, because if the foundation is not able to address that load, even design load, if you have a, for sure, which is a situation right now, if you have a higher volume of traffic and even at some point more weight, that also will be against the design. So if we build a better substructures, at least the maintenance of rehabilitation should it be done in the upper section rather than the lower section. So which means less interruption, less budget, and kind of all bump into that bubble of the geotechnical asset management, how we can protect our current foundation, and how we will try. Yeah, I know. So Alexander, sorry about that. Andrea just left. Maybe it's due to technical difficulties, but I have a plan B, which I'm gonna be able to do my presentation from my end. So don't worry about that. We have that covered. Okay, so what I will do is I will share. Okay, Andrea just joined, but I'm just gonna.
My
I'm just,
apologies,
no
everybody.
problem. No problem.
We
I
we
have
just
that covered. I
finished.
have that covered. Yeah. Yeah. So again, let's try to jump in. Let me know if you're able to see the presentation. At least
Yes, we
maybe
can
a
all
word.
see it.
Okay. Yeah.
Yeah.
So again, the idea about, or how to consider, how to pay a little bit more attention from design or as a consultant, like an overall attention on the substructure and how we can reduce or how we can build it better is, and again, Geogrids can do a lot or provide a lot of benefits when we say stiffening, confining, and at some point that separation that at sometimes it's not happening even with the subballast at place. So by doing that, we can again increase or add that enhancement factor, not just on the subballast, but also on the ballast. And we will talk the enhancement factor just in a few minutes, and how also can minimize the degradation of the modulus of the ballast over time. And this is also related how the rails works and how the vibration can also impact in aggregate movement, aggregate rotation, and at some point fragmentation, which again, all of them will lead into extending the ballast life, which also reduce maintenance and rehabilitations. Okay, so let me just give you a few more minutes, and also let me know if the video is working. And this is just a video installation that I want to show you on how even at some point Geogrid was not part of the design, how you can do some maintenance and incorporating Geogrids on your, in this case, on your between your subballast and ballast. And by again locking that material or restricting that aggregate movement and enhancing the performance of your ballast can make a lot of sense when we talk about less maintenance and less rehabilitation and have a better track stability or track designs. So this is just an example from construction point of views, and it will be a little bit more visual for you to understand how it can be done and how quickly also can be done. And again, makes a lot of sense when you say that it will help to decrease maintenance or major rehabilitation cycles, and as well as keep that aggregate at place. Let me just, it's a little bit noisy. Let me just skip into the video. And one of the actually tests that my guest speaker was managing on University of Illinois. This is a Penn State University, which also leads into the Illinois transportation industry. So this test that I'm going to talk about is a fully instrumented test, and the idea here is to evaluate or incorporate the smart rocks into the test. A smart rocks is a fake aggregate that has 360-degree sensor, and basically what you're gonna see in the next couple of slides is how the smart rocks or how the aggregate interacts with the reinforcement system by enhancing the performance of those. And when we talk about enhancing the performance, it's restricting the aggregate movement, also restricting or reducing any aggregate rotation and therefore fragmentation, and how that also, all those components together, how they can lead to a better performance overall. So again, this is the fully instrumented rail, and you will see how the rail is moving, which is mimics or simulate a real rail movement. And if you pay a little bit of attention when it says non-stabilized means no geogrid, and the rock and the edge, we'll see on real life how the rock or the aggregates are moving. And same in the other hand, in the right hand with stabilized with TX190L, which has the largest aperture geogrid, aims for ballast size of material. And you will see also the edge and how kind of the rock is reacting or is moving due to the track vibration. Okay, so at some point, the non-stabilized, you will see the rocks or the aggregate out of edge. Let me see if I can replicate that. So you will see that at some points goes in and out the Y. So later on, you will see what does mean. So when the edge goes in and out, means there is a no control section, and the aggregate basically is free to move. And you will see here on the upper section how we are able to reduce or control particle movements on the load when we talk about geogrids or non-geogrids. And same was when we say reduce particle rotation, that also can lead on aggregate or particle fragmentation. And for sure that will cause a lot of issues, particle fragmentations, when we talk about rail designs or rail performance. So then you will see how you can have a more controlled section with geogrids rather than without geogrids. So we have, and to be able to have designing tools, something that I will show you later on, is how we are able to back up ourselves, or how we're able to quantify or measure the benefit of geogrids when we talk about rails. And this is a summary that was given about some papers and some research where designers and consultants may be a little bit of scared when we talk about decrease or have a thinner section. But sometimes having a thicker section and not be able to control that type of failures is also not reliable. So in this specific case, by understanding the benefit of the geogrids and being able to be in the fully confined zone, or at some point fully confined and transition, so it makes a lot of sense when we want to have a better performance, as well as enhancing that layer coefficient of the aggregate. So again, most of the studies which can be, or you may have access into it, not just you are able to at some point decrease in certain percentage the aggregate thickness, or at some point even incorporate part of the existing soils without decreasing the thickness, but also be able to incorporate soils. You will have less excavation or less disposal costs, which at some point can be very expensive, but also how you can elongate or maximize design life and elongate any maintenance or rehabilitation cycles. So we also have a study that I believe is really cool, because when not everybody kind of gets into it, but how long geogrid has been installed for, at least for rails. So again, this is one of the first documented sites in 1983. in Alabama, and you see where Geogrid has been placed, actually, day of the installation. And again, talking about that, or how long it has to be, how long we can prove that the technology is going to work, and how the material is performing over the years, like mechanical properties, or even sometimes a visual inspection, how the material is still performing. And in 2019, after 28 years, example has been taken on the site and has been evaluated, and how is it still performing even after 28 years. So something that we can prove as not just in situ lab tests as a long-term design performance, but also in real action, how is it still performing. And again, stiffening the structure, reduce deflections under the loads, and after those tests, and also from the academia, which was my guest speaker introduction, he spent over 40 years or more on research on different type of geosynthetics, and there is no doubt or no question that Geogrids can certainly enhance substructure performance, and actually enhance, as well as I mentioned, or by creating that system, enhance the layer coefficient or the strength of the materials when it works in a system perspective. We also have, I don't want to just focus myself on the UX sample, which at some point may have more longevity, but we also want to name some of the local projects that we've done with Geogrids. And in this specific case, Geogrids also has a backup of the RIMA formula, so we will be able to provide a design that meets with the provincial and general standards within the sector. And part of the designing tools that we have is those designing tools are kind of flexible based on your priorities, based on your site conditions, and based on an overall the project perspective. So we can work on some assumptions, or when it's designed, and actually some numbers I give you options and which one of them makes sense. So in this specific Rutherford LRT, which was completed by beginning of the year, and right now it's in total operation, so it's a public project. The geotechnical engineer provided 3 types of scenarios, because again, due to the site conditions, they have different type of materials. In some sections, the subgrade was below 1%, or very, let's say, problematic section, very low bearing capacity on the ground. You have some medium values, which leads between soft and stiff conditions, and we have a stiff conditions CBR value above 3%, which in that case the geotechnical engineer did not incorporate or did not include the Geogrid. Okay, so and again, overall, we were able to save at least half of the thickness on the more aggressive scenario, and having a layer out place. Again, for more details on the design, feel free to reach out to me. We also have another test or another case study on rail applications for mostly software improvement on their rail track. And this specific case is in Lakeshore Corridor. And the main issue that they have is they were building a second line for the rail. They have an existing surface to meet, which is the one that you are seeing just beside. They have some subgrade issues, and due to some side challenges and utilities, they were not able to have the full thickness of the cross section to build. So in this case, we really want to enhance and maximize the benefit of the Geogrid, and was recommended to incorporate 2 layers in a total of almost 600 mil or above 2 feet. So to have a full confinement and having that system, or maximizing the benefit of that system at all times. We also have other type of situations, and I want to just explain how we can go from traditional up to the optimal, and what is the result that you may get into the 2 of them. So again, as we discussed already, and when we talk, we have ballast, subballast, in this case, foundation, and you have some fill and some in situ subgrade. So in the case of when and again, we can share more tools, not just designing tools, but also in situ tools that you can use. So when we talk about 1% CBR, so we will say that we're between soft and medium. And you also have some guidelines when you have just a visual inspection, you don't have the geotechnical report ready, or you also have some DCP or some borehole information, so you can correlate. Ultimately, CBR is just a unit, so you can correlate certain numbers and certain visual inspection out of that number. So we can say that we are not just able to reduce the thickness of the material, but to be able to go from a very low number, which is CBR1 between soft and medium, and bring that structure with certain thickness with the CBR 25% out of between the fill and the subballast. So also the subballast will take a lot of the weight, but how we can be able to enhance that cross section with Geogrid, something that it will take a lot of more thickness of aggregate to build. So we are able to build it kind of in a more cost-effective way. And same as you have 2%, that was the case of also Rutherford LRT with different scenarios, how we can still get that type of approach even with less thickness of material, and how you may have also a better, let's say, better shape or better numbers onto the subgrade, and how you're able also to reduce the amount of fill, subballast and ballast, and again, bump up the performance or not be able to compromise the performance. Talking about rails, we also not just design, but assist with a lot of intermodal facilities. CP and CN are one of the main users for that service. So if you have any inquiry or any projects coming up, one of the advantage that we can provide into your structure is reduce the removal or the unsuitable subgrade soils. So at the end of the day, if you're building or rebuilding, we do a lot of rehabilitations and designs, is how you can make it work or how you can maximize the benefits on the upper section rather than going into the subgrade. When we talk about rehabilitation, but when we talk about build, is how we can also enhance that separation layer and creating that system that will reinforce and will confine the fill if it's required, and overall the pavement structure. Again, reduce the cost of the asphalt pavement and reduce of the cost of the material, or enhancing the factor, the safety factor on both. For the purpose of this slide or this presentation, as I mentioned, I do have a demo if someone want to just interact and see how we can approach a possible, let's say, design with Geogrids. But overall, we're able not just to reduce overall the cost of the work, but also the time, the fuel, the water, and so many other environment factors that may be considered into your project. At some point, also be able to address some site conditions makes a lot of sense to build it better, not just thinner and with less money, but better. And again, this is part of our proposal or something that you can get out of that. We also have Geogrids on rail applications overall, not just when we have soft soils, which is in most of the cases that Geogrid is kind of well known, but in other type of applications. And having said that, I have my contact info here. If you want to expand further, I also have my guest speaker email or connection. If you want to expand, I also can do that. Expand the lab test that was presented here on the webinar. So if you want to have more the white paper or anything else, you can also do that. Meanwhile, I'm just gonna ask the audience if you have any further question, or if you also want to deploy or have that demo presentation of the software. If someone want to jump in with some values, or we'll be able to share some standard cross sections, and just to evaluate in real time the difference between a traditional type of systems versus an optimal system with Geogrids. So So if someone in the audience volunteer for, don't have to be a track designer, but at least if you have a fresh parameters that we can plug in into the software and see how this software performs under those conditions, if someone in the audience can jump in, or otherwise, I will leave the session to Andrea for questions and answers.
Isabel, I want to say that everything that you've presented is remarkable and it's impressive, and I want to thank you for your time. I also want to give people a moment to think about questions. I do have a question that was sent to us by email, so we could ask it for later, but I wanna hear first from the people who are here. Okay, so let me read this question that we have. One of our members asked, how much can I save in overall thickness of the subballast and ballast with the geogrid?
Yes, so out of this question, we have a kind of a general guideline. Ultimately, to provide exact answer, we need to understand the in situ conditions, and for sure, I mean, talking about traffic, talking about foundation or subgrade values, and also the desired way to build or cross section. But overall, we can say anywhere from 20 to 50% of the thickness of the ballast and subballast as a general number. We can still, again, provide that or give that sharp answer to 15, 20. It will depend on the site conditions. The other thing to, or the other way to look on that question is not just how you can reduce thickness of ballast and subballast, but at some point, even not reducing thickness, but in this case, is a question for even for our audience. We are able to reduce part of the existing aggregates into the new section. So whether you have a lower quality aggregates, we will still enhance the performance of those with Geogrids. So it's not just about reducing thickness of the cross section, ballast and subballast, but it also be at some point we're able to incorporate percentage if it's not all of the existing aggregates. So by doing that, we can certainly say that we're more sustainable rather than the traditional type of approach will be, say, is just removed and replace the whole thing, or at least the topsoil. I think Rashid had a question or raised the hand.
Yeah, can you hear me?
Yeah, I can hear you properly.
Yes.
Great presentation, Isabel. Thank you.
Thank you
for taking the time. I would kind of elaborate on the previous question in a different way. So most railroads look at it from a life cycle costing. It's obviously, it could have an increase at the initial construction costs, but it may increase the life of the ballast by X years. Do you have, and I'm sure you have done these studies internally, do you have anything you could share in sense of costing and life cycle costing specifically? Like, yes, you'll have to increase your spending in construction because it costs X dollars per track meter or track feet.
Yes.
But in the end, based on the studies that you've completed, ballast life will increase by 25%. So do you have something of the sort to share with publicly?
Yes, we are able. Let me just try to share again my screen and try to give you that as a perspective. So we have on tensorplus.com, the rail software, and I will try to address your question as much as I can because we have the new rail model available. The rail model is on the subballast stabilization. The ballast optimization is coming, but is available for us internally. So when we say, okay, it's not how much it will cost you to build, is what will be my safety factor, or if I build better than anticipated or better than design how much I can have it or for how long. So what we can say here is, let's just give you one, and again, if you also want to have another question after that, but let me just give you something that we can say, and let's keep that ballast thickness for 300 mil and subballast for, let's say, the D50s 90. Okay. Let's just, let's say the example of the 42 kPAs. So at some point, if we decided, because we have the ability to choose our subballast and ballast, and when we say we have the ability to choose the size of the material, the strength of the material, the better you have, or kind of the mixed material, if you have some recycle or reuse, you can also allocate the right factor on that. But we can build that even with a thicker, which at some point it will cost you a little bit more than the original, but we can say that the impact factor has been bumped from the unstabilized to the stabilized. We can quantify how much benefit you will have, and you have here some inputs. Ultimately, for how many years it will count, it will depend on the increasing traffic factor that you have over the years. Sometimes we come across with a increase in traffic over 7%, over 10%, over 15%. So that will certainly, that parameter that will also lead to the increase in performance. But overall, we can quantify the bearing capacity factor or the safety factor, and even going to the safety factor by ARIMA, anywhere from 2 to 5%. We can allocate those values and understand, again, giving you the total, and based on your increase in traffic, we can certainly say that will lead you to five years more, or at least it will give you to the, let's say, 50-year design life with a certainly lower maintenance or rehabilitation cycle, which again will lead into a better build structure. Sometimes what we have, I'm not sure if you agree with me, is even though the rail, in the case of Rutherford, the rail has been designed for 50 years design life, and at some point you may have even a shorter period of time of maintenance and rehabilitation. So other factor to look and try to understand this topic is how we can elongate those maintenance and rehabilitation cycle. And at some point, not just to meet with design life of 50 years, is how we can build it better than we have a less interruptions or line interruptions, as well as less spending into maintenance and rehabilitations.
Thank you for that response. I have another question, if
Sure.
A bit different. Has your product been used in transition zones, specifically for transitioning from a lower modulus to a higher modulus, kind of gradually to allow to reduce the rail deflections in the change?
Yes, and even to expand your question, is we have been suggesting on transition zones. What we have to be careful is that, and by understanding the capabilities of the system is not aimed to work as a patch. So if you have at some point, and you will have it in every single site, different type of soils, and that information is given by the borehole or the geotechnical report. It's very hard to find a uniform section. You always will have an average, a low value, medium value, high value. For design perspective, most of the time you take the lowest value available. But what we have to be careful when we go to transition zone is either we allocate a smooth transition, whether it's not a kind of a platform between the worst section and the okay or the best section. Because if you do that, so if you kind of reinforce on it or enhance kind of the worst performing section or the lower value section, what it will happen if it's side by side, this section will have, so the load that is going to occur on top will be the same for both sections. Well, the problem that we will have is on the reinforced section, it will be way more load to push in the beside section. So even though this is an okay subgrade performance section, the extra load that we'll have from the surface and from the sides, from the reinforced to the unreinforced, may lead also in type of failures. And that type of sections will work as a two different platforms. If you have a smooth transition, you are allocating that extra load into still a reinforced section until get the unreinforced with the okay performance subgrade. But that type of small advices, or from design perspective, small considerations makes a lot of sense. But yes, we have been suggesting and supporting transition zones, and actually Rutherford LRT, the case study that I just mentioned, has a lot of those.
Thank you.
Alexander is also raising the hand. I'm not sure if you're able to unmute and.
Go ahead, Alexander.
Yes, thank you for the presentation. It was excellent.
Thank you, Alexander.
Yeah, my question was mostly related to the study done at Penn State, where you were showing earlier that the geogrid could be placed in your layers of ballast. I was wondering, in case of extremely stiff subgrade, like on bedrock or on a structure, if you use the geogrid layer on over a sacrificial layer of ballast that you know is going to get crushed in your ballast section, will it reduce the degradation of the ballast over time?
But bear with me. So in this specific section where you said you have a very stiff soils, so you may not need to have that extra separation, but you're talking geogrids between the subballast and ballast, or between the subgrade and the subballast?
In the layer of ballast.
In the layer of ballast, yeah.
In your ballast section.
In your ballast section. So again, geogrid has, as I mentioned before during the presentation, a layer of influence. So in the case geogrid is below or has been placed below and on top of aggregate, it will have a layer of influence above and above and under. And that layer of influence, even though you are dealing with a very steep soils, which was actually one of the case with firm soils, you will have or you will be able to restrict aggregate movement, aggregate from fragmentation and rotation. And let me just show you very quickly the portion that I present, so it can be more visual. Bear with me just quickly. So even though when you have a firm soil, it's not this slide, my apologies. So when we say that we have a firm subgrade, that's why the layer of geogrid is not recommended to be just on top of that subgrade, because we already have a very firm surface to see that field or that subballast. So then the intention will be either to place a layer of geogrid between the subballast and ballast, or operate the section within the ballast section. And again, that layer of influence that I show you here, or that confinement zone, it will be on top and under.
And how much would you say this would, I don't know if we have numbers or, but how much can it improve the life cycle of the ballast stones and the reduction of degradation over time?
Yes, so that specific question, we have to address it by some numbers, because it's not the same design consideration. Let's say if we talk about just a heavy duty section versus heavy duty and medium duty, that will lead a lot of with some design parameters, but it can certainly enhance the ballast and sub-ballast performance where there is the influence section. Okay, and as per manufacturer, the minimum recommendation is the Geogrid needs to have 6 inches or 150 mil on top, so to have the maximum performance. So even within the ballast, if it's at least 250 mil or 6 inches away of the tracks, you will have the maximum performance, which exactly that number meets with the fully confined zone. So the layer of influence or the fully confined zone will be at max. Again, to be able to say that your ballast will last or will enhance the performance of the ballast by 30% or 40%, we will need to allocate some numbers, which again, I'm also welcome and willing to have that demo. And if you have some input values, we can plug the input values and see the performance. But overall, we can say that by restricting aggregate movement, aggregate rotation, and fragmentation, which again, that was part of the results of the Penn State University study, we can say that the layer itself will outperform, will be in a better conditions.
Great. Thank you very much.
Thank you.
Thank you very much to Rajid and Alexandra for your questions. They're really good questions. And definitely thank you, Isabel, for your time, your expertise, and for putting this together, which has probably taken you quite a bit of time. So I wanted to ask if you have any further questions, just because we are over the time. We want to invite you to email Isabel, email me to put you in touch with her. I will send an email to everybody with connections so that you can take this further and privately to discuss particular cases. Again, thank you so much to everybody involved. And I hope you have a wonderful afternoon.
Thank you again for all the attendees, and Andrea and Andrew for this opportunity. Thank you.
No,
You're very
thank you,
welcome.
Isabel. It was great.
And to everybody attending as well, we are uploading little by little the recordings and the information on our website, so our members will have full access to go back on this meeting and other meetings in the future. Follow us on social media so we can stay in touch. Visit us at trax.ca, and you'll learn more about what's coming here at the Trax web.
Thank you.
All right. Goodbye, everyone.
Bye-bye.